CLion a cross-platform IDE for C and C++. Download now.
Okay, so I'm Michael Hubbard. I'm an ASIC hardware and software developer. Today we are talking about why you would do runtime analysis without running a program, and why you need to be able to parse and analyze compilers without trusting the compiler commands. This level and aspect of my toolchain development is for NSA and Army level development response. It is not necessarily normal to have to make these levels of considerations and defense, especially after much of the Typhoon cleanup that's been done by the CISA organization in the US. But there are still not any good software tools that answer many of these analytical problems, and these solutions are met by numerous toolchain and macro files within said organizations. So that being said, what part of what you have to be able to do is not just visualize how a system works and what kind of gate time behavior it can have and what you can know about a system just by its relative hardware size, is because microchips have coprocessors and subprocessors, and depending on the build, no matter how I try to describe this, you can point at a hardware subset and call my language wrong. So one of the wonderful ways that microchips work now is out of order table execution. And this works at the compiler and JIT handoff level very well. It is part of some language optimization behavior many people noticed a couple times during development, is when the C Association brought the compiler more in alignment with out-of-order operation behavior. And one of the fun things my tool has shown me during development, from many different angles, is that most hardware developer companies are using out-of-order execution table optimization with GH Cordic optimization table methods. And what that means is that frames exactly how little binary is used to execute your code base and operations. And this is the level where you can't control it, but you absolutely can predict it, though it does take a large amount of work. So what happened, one of the things that would and did happen during the typhoon was CISA became an organization, and they were very honest that for years China had cracked the NSA security kernels. And what that meant when they tried to clean that up is they would continually find that China would get back in. And when we have a brother who is everywhere, he shouldn't necessarily have somebody else's sister with him when he's at work. And for the longest time, that is what was occurring, is we had somebody's very abusive little sister running around with our brother at work. And at the Typhoon level, bot automation had gotten to the point that in the data center, because they had bugs in the cameras and in the phones, you could not actually take a picture of a USB stick to get clearance to make a hardware change to a physical device in a secure center. So you could not remove a hacking tool inside of certain secure network sites. And some of this ended with these data centers closing. And these kinds of security threats are why Palantir is leaving Colorado. So part of what my tool does is it also allows you to do runtime prediction of your tool in a way that will also let you predict behavior across a full hardware stack to help you figure out exactly what position a device might be in. Because one of the things that has happened actually on accident and not maliciously is that hardware that is out of date with bug devices is still connected to the internet and still sometimes manages to help reinitiate a lot of these old Typhoon bugs. Um, so being able to have an advanced tool set that can help you locate out of date hardware that is still powered, still connected to the internet, but unfortunately inside of a building's walls, and sometimes inside of walls that have even gotten layers. Um, this is how you can do this without having to necessarily go around with a radar system or I don't think they call it the Rage Master anymore, and that's Rage, not Range. But there are ways to do that from a network engineer standpoint and from a hardware analyzation standpoint. They just do require many advanced tools that you have certain conditions in which they're lawful under. But we can do more of that with just basic math, and we can do more of that without having to have specialty kernel access C modules. And one of the ways we can do that is out of order operation optimization behavior was published by Intel and ARM and is very public. GH Cordic is a math table system. It's very public. It was implemented in many C programs and kernels as a binary tool and made made a certain college student billions of dollars. And that method together is what gives us a framing of how worst possible behavior and best possible runtime behavior can occur. And that's one slice of what you need to be able to look at all the different pieces of what can go wrong and when with different code syntax and different binary usage implementations. And I think that's all I can really get into today is that many common table methods and math tools have been published and exist. They're just not actually bundled and put together in a way for compiler analysis and protection for situations where somebody is actually millions of miles away messing with your personal compiler. And there are ways to respond to that without having to have an offline system. And it's my hope to provide you all with, if these situations ever happen to us again, you have some very fast, easy response tools. Thank you, and I'll hand this back to Phil.